Now that we've finished the switching portion of the JNCIS-ENT, I thought it would be a good idea to actually test our knowledge. So what I've done, and I haven't looked at these things previously, what I've done, I've just opened up this certification practice exam, and if this works, we're going to go through the switching portion and see if there's any gaps in our knowledge, and if not, then we'll move on to the routing section. Now this is just a practice test on the Juniper website. I don't actually believe in anything like dumps or anything like that. So if you've done the work, you should have the prerequisite knowledge to actually pass these exams. And I'm looking for the JNCIS-ENT. JNCIS-EN. It says 1 of 1. Okay, here it is. The Enterprise Routing and Switching Specialist. Let's click this. This practice test is designed to help you prepare for the live exam. The passing score has been set to 70, which is not necessarily the passing score. You will have unlimited attempts, however the questions will not change. Ah, right, okay. So let's start this. Okay, something looks like it's loading now. 40 questions, unlimited exam attempts, 70% is the passing score. Good. How many untagged VLANs can be configured on an EX series switch port? How many untagged VLANs can be configured on an EX series switch port? So an untagged VLAN is the one that's connecting to the host. From my understanding, I would say just one. One untagged VLAN can be configured on an EX series switch port. So the untagged VLAN is the VLAN which is connecting to an access port going to a host. So I think it's one. All right, let's go. Next one. Which statement is correct about trunk ports? Trunk ports must have an IRB assigned to accept VLAN tagged traffic. Oh my goodness. So this already is making me think that I haven't covered IRB interfaces in the course. We will have to go back and cover IRB interfaces, but that's fine. That's why we do these practice tests, to see if the course is complete. Trunk ports must have an IRB assigned to accept untagged traffic. No, I wouldn't say that. By default, a trunk port can have only a single VLAN assigned. Well, no, because they've got to take lots of VLANs between switches. By default, trunk ports accept only VLAN tagged traffic. Yes, that would be my answer. They don't need an IRB. So in my mind now, an IRB must be like what on other vendors we'd call SVI, a switched virtual interface. And that's only to route between VLANs. Okay, let's go next. Is this another switching question? Yes, it is. Referring to the exhibit, all users connected to the same VLAN can communicate with each other, but not with users on other VLANs in this network. What must be configured to enable communication between the VLANs? As I said previously, I think this is what an IRB does, but we will cover that in a future video. So a single logical IRB interface must be created and assigned to all three VLANs. Well, no, I think they will need their own IRB interface. A separate routing device is required to forward traffic between the configured VLANs, not unless you're doing route on a stick. A logical IRB interface must be created and assigned to each VLAN. Well, that's my answer. The switch ports to which users are connected should be configured as trunk ports. No, because trunk ports are only used between switches, yeah? Which two mechanisms populate the switching table and ensure that the switching table remains current? Oof. Well, flooding must be one. So we know that when they receive a packet, a switch will flood out all interfaces apart from the interface that it received it on if it doesn't have the MAC address. Which two mechanisms populate the switching table and ensure that the switching table remains current? Flooding, it's not blocking, but is it learning or listening? I honestly don't know. I know that one of them is flooding, and as an educated guess, I would say learning, because it has to learn the MAC addresses to populate its CAM table. So I would say learning and flooding. Which three mechanisms are associated with the bridging process? Oh my gosh. Got no idea. And I'm hoping that this will be covered when I go into the IRB. So I'll have to leave this one. This is a gap in the knowledge. Blocking, filtering, flooding, listening, aging. I honestly don't know. So move on to the next one. You manage the layer 2 network shown in the exhibit. You experience a failure on the GE000 link between switch 1 and switch 2. So this link here. Which statement is correct about the expected behavior? Switch 2 will remove itself from the rapid spanning tree topology. No. Switch 2's GE002 port role and state will remain as designated and forwarding. Maybe. Switch 2's GE002 port role and state will transition to root and forwarding. So it needs a path to the root port. So I'd say this one is correct. Switch 2 will become the root bridge for a separate rapid spanning tree topology. No. So it's going to be this one, number 3. Switch 2's GE002 port role and state will transition to root, needs a path to the root bridge, and forwarding. Based on the output shown in the exhibit, which statement is correct? The GE0015 interface is using the default port cost. Well, I don't know. I don't know what the default port cost on an EX switch is. I know on the QFX it's 2000 because they use 10 gig interfaces. I'm going to presume that the default port cost is 100 meg. Oh no, if it's G, it's gig. So a gigabit interface has, if 10 gig is 2000, then gig will be 20,000. So no, this switch has been elected as the root bridge. Well, all its ports are forwarding and designated, so I say this is correct. So that's my first one. The GE009 interface is using the default priority value. The default priority value. Well, no, because the default priority value is 32,768 and they're all as 8,192, so no. This switch has a bridge priority of 32k, no. So this is the answer. This switch has been elected as the root bridge. Which are the 3 possible port states when using rapid spanning tree? So we have discarding, forwarding. I thought listening and learning. Oh, listening and blocking are in one, so learning. So discarding, learning, and forwarding. Which 2 elements are used to create the spanning tree bridge ID? So it's the MAC address and the bridge port value. Which 2 port security features use the DHCP snooping database for additional port security? So I thought IP source guard, MAC learning, and dynamic. Okay, not MAC learning. I don't know what that is. So it's IP source guard and dynamic ARP inspection. The one I thought with MAC was MAC limiting, not MAC learning. So we've got IP source guard and dynamic ARP inspection. And so far this is going really well because we've covered most of these things in our switching course so far. It seems pretty straightforward, apart from the IRB sections obviously. You are enabling dynamic ARP inspection on an EX4300 switch. Which service is enabled by default in this scenario? Well, we know that that's DHCP snooping. Just because we've got the 3 of IP source guard, MAC limiting, and, well, dynamic ARP inspection. When you enable those, then DHCP snooping is enabled by default. Not sure how many questions we've been through so far. I wasn't keeping count. Which statement is true about layer 2 firewall filters on EX series switches? Now, you see this is a bit weak for us because we're using the QFX, but the theory should be the same. So they are stateless and evaluated by the forwarding plane. Well, that sounds good already. They're stateless, I know that. They are stateless, stateful and evaluated by the forwarding plane. No. Oh, so it's either, are they evaluated by the forwarding plane or the control plane? I'm sure it's the forwarding plane. So they are stateless and evaluated by the forwarding plane. I'm sure I actually mentioned that in one of the videos as well. Which statement about configuring persistent MAC learning is correct? Persistent MAC learning flushes dynamically learned MAC addresses on reboots. No. Persistent MAC learning can be configured on redundant trunk groups. No. Persistent MAC learning requires 802.1x authentication. I don't think so. Persistent mat learning can be configured on access mode interfaces. That's the one for me. And we went through persistent mat learning in, was it the MAC limiting video? I think it was. Okay, so this is a layer 3 question. Haven't got there yet. That'll be covered in the next section. But I think so far we're doing quite well in the switching section. This is another routing question, so let's move on. Layer 3. And what I might do is that any layer 3 questions, I might just cut those out of the video and we'll concentrate on the layer 2. And then later on, when we finish the routing section, we'll come back to this and do it completely and see what our score is. So we won't get a score so far, but we will have visibility of what kind of questions they ask. Alright, we've actually come back. I've gone through about an extra 20 questions and they were all routing. This is the first one that we've come back to layer 2 switching. So what are 2 benefits of 802.3 AD link aggregation? And this is a lag. So this is link aggregation protocol. It says choose 2. Now, anytime I see anything that says redundancy, that's automatically, in my mind, something to do with link aggregation. So if one link goes down, it can still forward across those paths. It ensures symmetrical paths. Don't know what that means. It increases bandwidth. Yes. It simplifies interface configuration. No, because you've got to do more configuration. It creates physical layer redundancy, or it ensures symmetrical paths. I don't think it ensures symmetrical paths, so my answer is A and C. Which command verifies that graceful routing engine switchover GRES is operational? I think that it's going to be this last one. Show system switchover on the backup RE. Right, next. Which 2 statements describe non-stop routing, NSR? NSR provides high availability with multiple routing engines. NSR rapidly detects link failures. NSR provides routing loop protection. No, I think it's these 2. NSR provides high availability with multiple routing engines, and NSR requires GRES to function properly. You are adding a new EX4300 member switch to your existing virtual chassis. However, the new member is not running the same Junos version as the other members by default. By default, what is the expected behavior in this scenario? The new switch will be assigned a member ID and then placed in an inactive state? I don't think so. The new switch is not recognized by the virtual chassis? No. The virtual chassis will transition into a split brain situation? No. The new switch will automatically pull the correct version from the master router and perform the necessary upgrade. I think it's this one. It may be the first one. I'm not sure on the EX. As we know, virtual chassis did not work in our lab, but we went through the theory. Okay. And that is it for the exam. Now, I haven't submitted anything, and I don't think it will allow me to submit, but these are the type of questions I'm expecting to see when I go to take the exam. Okay, and it just goes back round to the beginning. So thanks, guys. I need to go and finish an IRB course now, which I will start putting together. But apart from the IRB section, I think we pretty much covered everything else, and it's time to move on to the routing section. Thanks for watching. I'll see you in the next video.